Alrighty guys, so I am back at my desk now instead of doing the board. That's why Blackboard's behind me. If you take a look at your next assignment, it's called a penny flip. So at home, you are going to need a penny or some type of coin. You could use a nickel if you want to, just anything that has heads and a tails on it. Does not have to be a penny. Anything will work. I have it loaded in here in Kami for you, and I'm going to pull up the Word document on my end. So if you're in school, you'll get the Word document. Otherwise, you can use the Kami version of it. Same exact thing. It might be a good time to rope in your parents or maybe a brother or sister who's at home to help you out with this, because otherwise, if you're doing it on your own, it is going to take you a little more time. And we're doing this activity today and tomorrow. So we're doing it 2 days in school. So you'll also have 2 days at home to do it. So you don't got to rush through and try to do it all in one day. So in this lab, you're going to be making predictions using Punnett squares and then use pennies or any coin to simulate the crosses. The results from the Punnett square can then be compared to the actual data. The trait you are looking at is the gene that codes for short big toes in humans. Capital T is going to represent the dominant allele for a short big toe, which sounds really confusing, right? Why would a capital T be a short big toe? And a lowercase t is going to be for a long big toe. The photo shows a person with a short big toe. The following genotypes are possible. Fill in the phenotypes for them. A lot of people, if you look at your own feet, you would think that your big toe would be the longest one and then it would go down like a nice little slant. Most of the time, that's not actually how it works. Your big toe is slightly shorter, or it's the same exact size as that second toe. The second toe is longer for a lot of people. So 2 capital T's is going to be a short toe. The heterozygous form is also going to be short because all you need is 1 capital T. And the 2 little ones are going to be long. Part 1 here, use a Punnett square to predict the ratio of offspring in a cross where the parents are both heterozygous. So I have this square made up for you already, big T, little t, big T, little t. And you are going to go on ahead and fill that in there. So you should have your big T's moving down, big T moves across, little t moves down, little t moves across. You'll end up with 2 big T's, big and little, and 2 little t's. So when we look at the portion of the outspring with a short toe, you're going to have a 75% chance, or 3 out of the 4 blocks. For a long toe, it's going to be 1 out of the 4, or a 25% chance, and you can figure that out by simply doing that cross. This is where you may need some help. In order to determine the actual ratios by using pennies to represent the crosses, you have 2 pennies. So you need 2 different coins, and you can either work with a partner and each have 1 penny, or you would do it by yourself and have 2. Heads is going to represent a capital T. Tails is going to represent a lowercase t. You and your partner will flip your pennies and determine the genotype. So you do 1 practice round. I'm not going to flip this coin because it's going to make a really loud cling, but you would each do 1, and you would tell me, if you have heads or tails, make it accordingly and tell me if it's going to be long or short. Part 1, to determine the actual ratio, you will flip the coins 100 times, recording in the table below how often each combination came up. You're going to use tally marks to record your data, then summarize this as a number. We're all about ratios when we're working with Punnett squares, so we really want to have a true representation of how many times homozygous recessive comes up versus the other 2 options, dominant or heterozygous, which is also dominant. So you'll use tally marks going across here, and you're doing it for a total of 100. So your numbers over here on the side should equal 100 by the end of it. Then you'll look at your numbers there, and you're going to tell me, short toe, how many did you get in total? Long toe, how many did you get in total? So if you had, say 60 between the homozygous dominant and the heterozygous, you would put a total of 60 short toes. And then that would give you 40 for your homozygous recessive long toes. Since you flipped 100 times, your totals above represent a percentage. Your proportions from the Punnett square in your prediction can also represent a percentage. 1/4 is 25%, 2/4 is 50%, etc. Compare your predicted ratios to your actual ratios in the chart below. So look at the one from the square. So you did a Punnett square up at the top here. What was your ratio for your proportion versus what you actually got? So you only have one square to do. Keep that in mind. It was one square you did at the very top. Then you're going to move on to part 2, and you're going to repeat the procedure for parents who are big T, little t, and two little t's. First, make a prediction by setting up a Punnett square. So you're going to put your heterozygous form across the top, your homozygous recessive form across the bottom. Do that square and tell me how many would have a short toe versus how many would have a long toe. This time you will not need a partner. You can do it completely by yourself. You only need to flip one coin. The other one is always going to be recessive, so you only have two options here. You could either get heterozygous or homozygous recessive. That's why you're only using one coin, because that other one is always going to be the recessive form of the tails. So you'll do that one again 100 times, get your totals. You will never be able to get homozygous dominant because that wasn't one of our options. Compare the predicted ratios to the cross from the actual ratios. So again, you're looking up here. What was the prediction? What percentage would you have gotten with a short toe versus a long toe? And then from your flips, was it close? Was it not close? And you'll answer these 2 analysis questions. So again, you have 2 days to complete this assignment. And since we're doing it on a Friday and a Monday, you actually have the weekend as well. If you just don't feel like flipping it today, that's fine. But again, it is due at the end of the period on Monday. Alrighty, that is it from me for today. I'll see you soon.